So, hi, my name is Jon Benedict, and I work for the Nevada Division of Water Resources. This office is sometimes called the Office of the State Engineer as well, for those that are maybe more familiar with that terminology. The principal responsibility of our office is to administer water rights for the state of Nevada. And one of the few quantitative tools that our office uses for administration of groundwater resources is a value called perennial yield. For my presentation, I'm going to provide some basic information on what perennial yield is, what its relevance is for Nevada and the Carson River watershed, and then describe a couple of specific examples both in the Carson River watershed and outside the watershed to illustrate the fact that while perennial yield in Nevada may appear to be a hard line in the sand from an administrative perspective, it is and should be subject to periodic revision or reconsideration, not only in the Carson River watershed, but across the entire state of Nevada. So for Nevada, perennial yield measures, as measured in acre-feet of groundwater, have been established by our office for each of the 256 hydrographic areas within the state. And this map shows the outline of those, if you can see that. Most of these established values are based on studies by the U.S. Geological Survey that were completed back in the 1950s, 1960s, and 1970s. For folks that are familiar with water rights in Nevada, the perennial yield is a quantitative line in the sand regarding groundwater availability and whether a basin can or should be closed to additional groundwater use. It also represents a key threshold that allows for special management tools such as curtailment or the designation of critical management areas where over-appropriation of groundwater is causing adverse impacts. So, as I hope it's apparent to everybody here, my analogy between the perennial yield and a line in the sand follows from the fact that perennial yield is a hardline quantity of water that not only provides a measure of any given basin's groundwater resource, but it's also a key threshold value that the state engineer needs to consider in order to use statutorily available tools to manage fully or over-appropriated basins. But these specific established perennial yield values have a degree of scientific uncertainty and are also dependent on water policy. And so they can and should change as science improves and as water policy shifts. So I've taken a couple of slides from a USGS presentation on perennial yield, and I want to give credit to them for these. But in Western water law, you'll come across a variety of terms like perennial yield, including safe yield, basin yield, sustainable yield. And all of these terms essentially mean kind of the same thing, and that is a fixed quantity of water that can be safely removed from an aquifer system over time without causing undesirable effects. So that's kind of what perennial yield is. Some of these terms are more technically based than others, but they all tend to focus on the availability of water as dictated by a basin's water budget. Now, this water budget is an estimated amount of groundwater that annually cycles through a basin's primary aquifer. So let's look at these groundwater budgets and where they come from, as a matter of fact. So before pumping begins, a system like this is under pre-development conditions, and only the natural components of the water budget are considered. And in this case, inflow equals outflow. So what comes into this basin is the same as what goes out in terms of water. The inflow here is shown in green, and it represents recharge from precipitation within the watershed, water that infiltrates into the ground from streams, seepage from irrigation waters, and also subsurface inflows that may come from adjacent basins. The outflow, or the discharge component, includes water that discharges to streams or springs, evaporation from the soil, or plant consumption, or what's called evapotranspiration, or sometimes it's shortened to ET, from those kinds of vegetation whose roots tap into the water table. Now, once pumping begins in a basin, these groundwater withdrawals from pumping result in water level declines. And at this point, aquifer storage needs to be taken into account, and pumping becomes part of that water budget. So all of these components are measured or estimated through basin scale groundwater resource studies. And in Nevada, most of these studies were conducted back in the 50s through the 70s. And most of the state's perennial yield values were adopted by the state engineer from those original studies. So let's take a look at Nevada's perennial yield definition. This comes from a 1971 report called the Water Planning Report #3 that was put out by our office. And what it says is that the perennial yield is the maximum amount of groundwater that can be salvaged each year over the long term without depleting the groundwater reservoir. Perennial yield is ultimately limited to the maximum amount of natural discharge that can be utilized for beneficial use. The perennial yield cannot be more than the natural recharge to a groundwater basin, and in some cases is less. So what you'll note here is there's 3 different sentences here that quantify or describe perennial yield, and each one a little bit differently. And to me, this sort of suggests that there are several ways to estimate perennial yield for any given basin. And also, it's noted that this estimated value has certain limits. You can see the word maximum in there quite a bit. And these limits may or may not be entirely known. So in my view, just as there are these 3 sentences that describe perennial yield a little bit differently, there are also 3 criteria that are suggested by this definition that can each serve to help define this perennial yield estimate. Again, key to the groundwater resource and kind of understanding the availability of water for groundwater use. And these criteria are the water budget, water levels or water level stabilization, and what I call the capturability of water. And you can see these in the different parts of the definition of perennial yield. Oops, let's see here. Okay, so for the first one, water budget, this is really what the USGS studies back in the 50s and 60s focused on. They were largely limited to making a first pass estimate of perennial yield in the various hydrographic areas in the state based on the water budget, commonly focusing on the discharge component, but occasionally recommending a perennial yield based on the recharge component, particularly in hydrographic areas like the Carson River watershed where there's a through-going stream. Water level stabilization, this is kind of a key metric to ensure that groundwater systems aren't being depleted. These early perennial yield estimates by the USGS typically didn't directly consider water levels because that data just wasn't available. But since that time, water level monitoring by the USGS and by our office has kind of filled that out. And these data really help to tell a fuller story with respect to water level declines in over pumped areas, providing sort of the kind of information needed to help assess areas where perennial yield may either need to be reconsidered because it's too high or because it's too low. This third criteria that I call capturability of water, this is an important one that's not nearly as straightforward as the other 2. And so I want to reread this language in our perennial yield. It says perennial yield is ultimately limited to the maximum amount of natural discharge that can be utilized for beneficial use. Note here that this utilization of natural discharge is really just another way to say that pumping takes the place of or captures some part of the natural discharge within a system. So I think it's important to recognize that this part of the perennial yield definition appears to recognize that this capturability criteria is the ultimate determinant of perennial yield. It suggests that at the end of the day, only the part of the natural discharge that's actually available to be captured and used should be included in a perennial yield estimate. So I want to kind of drill into this a little bit deeper and talk about what this capturability means and maybe a better way to think about it. One thing we commonly do in our field in terms of talking about capturability is look at it in terms of what are called capture curves that describe where water pumped by a well comes from. And I'm showing one of those on the left lower I'm also showing a cross section above that of a hypothetical well. So for this capture curve, when a pumping well first begins to pump, the initial pumping of that well takes 100% of its water out of the groundwater system and causes water level declines. It forms a cone of depression around that well. As pumping continues, that cone of depression expands out. This is kind of shown in the cross section up above. And that cone of depression, or the lowering of the water table, encroaches on things like vegetation that relies on the water table, or a spring, or maybe a stream. And it actually begins to capture water from those discharge sources. Over time, the more and more you pump, the more of the water that's being pumped is captured from those discharge sites. And over time, ultimately, the water levels stabilize, and 100% of that water will come from discharge from these other natural discharge components. And really, the thought about perennial yield is to stabilize the water level, you have to capture that water from some other place other than within the aquifer itself. It inevitably has to be a discharge source. So on the right, what I'm showing here is kind of a conversion of that capture curve on the bottom in terms of sort of this concept of perennial yield. And really, it's exactly the same curve, but I've changed the names of a couple of the lines on it. So what I've done here is the one on the left shows capture of evapotranspiration in the dashed blue line, and capture, for example, of stream and spring flow in the yellow line. And I've changed the names of those to capture of perennial yield, or perennial yield capture, and inadvertent or unavailable capture. And the concept here is that in this perennial yield estimate, there are natural discharges that are considered fair game, if you will. And commonly it's the phreatophytic vegetation within a basin. Whereas things like streams and springs may already have water rights on them, they may already be used. And so typically if a well pumps and captures that, that could be a conflict to somebody else's water right. And so those really shouldn't be considered part of this perennial yield value for any given basin. Sometimes they are, though. So this capturability of water criteria is really coming into play more and more as the demand on our water resource grows, and we learn more about these hydrologic interactions between various source waters in Nevada. There's also a greater need to consider what should and should not be available to groundwater pumping from a conjunctive management perspective, which is something that the state's looking more and more closely at. So now I'm going to move on to a couple of examples that illustrate some of the kinds of reconsiderations of perennial yield that have been made in the recent past or are currently being contemplated by our office in specific basins in Nevada. As I go through these couple of examples, you'll probably see how one or more of these three criteria come into play with respect to how perennial yield estimates are made and revised in the state of Nevada. First example comes from Dayton Valley. So this is just east of Carson City. For this basin, the USGS made estimates of the water budget components back in 1975, but it didn't specifically recommend a perennial yield value for the basin. However, the state engineer used those results to establish an initial perennial yield here of 7,900 acre feet. Then 10 years later, oops, excuse me. Then 10 years later in 1984, the state engineer revised that value upward to 9,445 acre feet. Now the difference between these two values was that the 7,900 acre feet value only included recharge by precipitation in the basin, and the 9,445 acre feet included both that recharge as well as interbasin flow, or flow coming in from an adjacent basin. Now, the reason why this change was made isn't clear in the historical record, but it's likely simply to be the state engineer's perspective on what should and shouldn't be included in a perennial yield value. Then 25 years later, in 2008, the state engineer revised that perennial yield once again, noting that the basin recharge, again, this precipitation on the basin, should be the measure of perennial yield, and that underflow into the Dayton Valley was reserved for the upgradient basin, in this case, Steeple Valley. But really the most unusual thing about this that the state engineer did here was he revised that perennial yield to a range of from 8,000 to 20,000 acre feet based on the uncertainty in the science on what constituted basin recharge and what those estimates were. So this is kind of a rare example of a case where the state engineer has accommodated scientific uncertainty in the establishment of perennial yield. And arguably, this may be a difficult thing to manage with when you've got a number that's got such a wide range, but that's just the way it is. Second example, this one comes from outside the Carson River watershed, but it could have some implications with respect to this area. And perhaps maybe it would have implications for any area that has a through-going river within it in the state. So this example describes the capturability conflict issue tied to the groundwater surface water interactions, specifically in the Humboldt River region. So there are 34 hydrographic areas in this region, and the perennial yield values here are pretty much limited to just the groundwater evapotranspiration. So here, the acceptable amount of water available represents that water that could be salvaged from ET. So that means that any groundwater that discharges to the river isn't included in part of the perennial yield. So in this region, our office has been focusing on the conflict aspect of capturability. Here, any capture of surface water by pumping can result in conflict to senior surface water users. And because areas of groundwater ET and locations of these hydraulically connected streams occur in the same general area, it's almost impossible for pumping to capture just the ET without also capturing some of the river. And so that becomes conflict. So what this does, it makes a substantial portion of the ET discharge otherwise considered available as part of perennial yield unavailable due to the potential conflict tied to that effect of unavoidable stream capture. So for the last 7 years, we've been denying any new appropriations within this region for groundwater based on the simple fact that pumping in that area is inevitably going to capture some of the surface water flow that's fully appropriated by senior surface water users. So here, the solution that we're coming up with, at least as an initial step, is to start granting new groundwater appropriations that would otherwise capture some amount of stream flow, as long as that conflict is actually avoided by offsetting the capture by either withdrawing a different existing groundwater right or by securing a separate surface water right whose water is left in the river to replace that capture. So this means we're solving this problem, or at least a part of this problem administratively, by using a second water right to replace what I call the unacceptable capture in this curve. And this is all spelled out in an order that the state engineer issued earlier this year. Actually, I think it was in the winter. That order is order 1329. So this example illustrates a tricky question of how to properly manage water based on perennial yield in regions where there is groundwater and surface water interactions that occur and the stream is connected to a groundwater system. So what does this experience tell us, or what does it mean to water users in the Carson River watershed? Well, first off, there's a bunch of similarities here. And I think the most important ones are this through-going river, a connected river that is hydraulically connected to the water table in the basins. Another, the obvious recognition that surface water capture can occur when you pump groundwater. And then the final one is, that's important, really important, is surface water users tend to be senior to the junior groundwater rights. And so in Nevada water law, those senior surface water rights have a higher value and need to be served before junior water rights are. There are also some important differences. In the Humboldt River region, the surface water is managed by a state decree, whereas here it's a federal decree. In the Humboldt River region, there's been alleged conflict by the surface water users. Here, that might be a concern in the future, but currently I haven't heard of any issues there. Third one, the perennial yield was calculated differently. In the Humboldt River region, it was based on evapotranspiration discharge. In most of the Carson River watershed, the perennial yield represents the recharge into the basin. And the last one, which I think is quite important, is that in the Humboldt, groundwater that's tributary to surface water, in other words, groundwater that discharges to the river, is considered to be part of the surface water decree. So that water is actually water that's considered to belong to the surface water users. Whereas in the Carson River watershed, it's been ruled in certain state engineers that any groundwater that comes into the basin belongs to the groundwater system. So to the extent that that's true, groundwater that discharges to the river is considered part of the groundwater. It isn't part of the decree there. That's important. So bottom line here is that while perennial yield value is an important and useful tool, it's not the only criteria, that needs to be considered when looking at a water resource problem, particularly at this point in time when conjunctive management of surface water and groundwater is expressly described as a policy for the state of Nevada. And in light of these similarities between the Humboldt River region and the Carson River watershed, I'd suggest that it's worthwhile for stakeholders here to pay some attention to what goes on in the Humboldt River region with respect to this capturability conflict issue down the road. Last slide. So in closing, I'd say that the perennial yield values, it really is a useful tool for managing Nevada's groundwater resource, and that includes this watershed. But that these perennial yield values are always worthy of revision based on new science and changes in Nevada's administrative framework. And then lastly, totally important to closely consider the role of capturability of conflict in both the determination of perennial yield as well as the management of our water resource. So with that, I think I've gone a little long, but I might have a little bit of time for questions.